than land use, which is the biggest water user in terms of agriculture. And agriculture is particularly difficult. And as far as agriculture is concerned, you need to know, well, what is the land use currently? Where is agriculture being grown? We don't even have a really good handle on that right now. Even with all the satellite measurements that we can do, there are disagreements between the land use data sets. And so we've tried to make some improvements in those within Watch. One of the ways that we do it is by agricultural modeling. So we look at what land use is there according to the land use data sets that we have. And then we also look at crop potential, and we compare the climates to crop catalogs to see where crops can be grown. And then we compare those to the land use maps to say, well, what's the most suitable land for crop growth? And in most cases, that's where crops should be grown currently. And so we improve our data sets, and even the statistical data. We look at the statistical data, we downscale it according to the information that we have on crop growth. And so we have a good idea, we can gain a good idea of where the crop production currently is and how much it is. We use economic models to compare supply and demand now and into the future, and then we see how much more land would be necessary. One of the issues in agriculture is we're already using the most suitable land, and there's not much greater land extent that we can use for agriculture. So the answer is we need to intensify the agricultural land use and the land that we already have. And that's difficult, but there are big gaps between the potential and what is actually being grown in many areas of the world, and so there are huge improvements. In some cases, in Africa, for instance, only 20% of the potential is being realized. So there are vast potentials for improvement.